Hello.
And they used to come and say, how does this washing machine works?
So this is from the Ruby core mailing list or a bug and issue tracker. A few years ago, 5 years ago, actually a little bit more than that by now, Shugo Maeda wrote this issue about adding a new feature to the language. Metz had kind of talked about that for a short while. It was called the Refinements. It happened 5 years ago. He made a proposal, he wrote an implementation. Then nothing happens for like 2 or 3 years, okay? 3 years ago, right before Ruby 2 comes out, the discussion starts again, and it becomes drama, real quick. A huge discussion. Yeah, the Larsen thing. This is not my normal voice. Hello again. Can you take these off? I could do this all day. So, matter of fact, right before Ruby 2 comes out, the discussion about refinements starts again, and it becomes a fight, essentially. So on one side, there are Metz and the other Ruby core submitters. On the other side, there are people from the community who have a presence in the community, like the JRuby people. And some of these people are saying, hey, this feature is dangerous. It might kill the language. That's what they said. They fight for a while. Ultimately, refinements finally get toned down somehow, and they make their way into Ruby 2. So that was 5 years ago when it started, about 3 years ago when this was closed, and it made it into Ruby 2. And now we have refinements, and everybody's using them, right? I mean, if you use refinements, raise your hand. Look at all those hands. Huh? This was a total failure, right? I mean, it was supposed to be one of the most important new features in the language. Since the very beginning, it kind of faded away, and nobody knows why. It's like, if you ask people, they will go like, oh yeah, they are no good, nobody's using them, but nobody knows why, really. It's hard to verbalize. So this is what I want to do. Now I take like half an hour. I tell you all I know about refinements, not all of it, literally, but a lot of stuff so you can make up your mind. At least you can keep avoiding them, but at least you will know exactly why you're avoiding them, okay? It's going to be a technical talk. So let's start from the very beginning, why refinements exist. What's the problem that refinements were set to solve in the very beginning? So in Ruby, you can do this. You can reopen a class that already exists, in this case, the string class, and put a method in there. Or redefine a method that already exists. In this case, we have a new method called display that prints out the string itself, or returns, sorry, the string itself, and it's all happy and full of nice little Japanese icons. So now when you say, for example, hello display, everybody's super happy. Yoo-hoo. Okay? That's it. Okay. So this is a feature that some people call dynamic class scope or open classes. Most of us just call it with a term that is vaguely negative. We call it monkey patching. Okay? That's what monkey patching is. What is monkey patching for? Why do we have monkey patching? Well, there are like 5 or 6 use cases you can probably think of. They do change the language. Ruby is defined by this. It would be a very different language without monkey patching. It would feel like Python, that is a great language, but it's not Ruby anymore. So what's the point? Amongst all the use cases, you can probably select a couple of main use cases that you see all the time. First, convenience methods. In Rails, for example, you can say 1 hour plus 20 minutes, like this. Of course, hour and minutes are methods, right? And they were added to numbers to, I don't know, fixed num, integer, I don't know what's the fashionable number class these days. And is this necessary? No. You could say our parentheses 1, for example. You could have regular functions or top-level methods, right? But it looks good. And in Ruby, it's important to write code that looks good. We care about that. It's actually part of the language. So you cannot do this without monkey patching. Here is another use case that is like this use case, taking a few steps further. Once you start going crazy with monkey patching, you get to a point where you build things, structures that actually look like a specific language for whatever you want to do. This is an example from RSpec. I have it here because it's the textbook example of a domain-specific language in Ruby, even though this is not valid RSpec anymore. This is a pretty old version of RSpec. Still, if you look at it, it looks great. It reads like English. It's very expressive. And you cannot do this if you don't have monkey patching, because if you look at should must be a method. And it must be a method on, I don't know, integers, object, basic object, the kernel module. I don't know, it's a method somewhere. It was put in there with monkey patching. So this is just to say, we care about monkey patching. It's one of the basic features of Ruby. It's awesome, okay? Here is my original example of monkey patching again. So what's wrong with monkey patching? What's the problem? The problem is that, for example, this innocent piece of code breaks Ruby. Can you tell me why?
If somebody else do the same.
You are close, but no cigar. Nobody knows why. Xavier? I defined a method called display, thinking, hey, I have a nice new method, but there is already a method called display in Ruby. I bet you never used it, but it's there. So I just broke Ruby by overwriting, overwriting, actually, a method that already exists, which I didn't know about. I did, of course, but, you know, that's why the example is valid. Yeah, it does weird stuff. It takes a display port and it displays an object, whatever. My point is, monkey patching is evil because it's global. Global, bad luck. Global, bad. We don't want global stuff in programming, especially if we have a very large program. You make a global change, you never know. As you said rightly, maybe somebody else defined a display method. Maybe somebody defined a display method in a gem that is being used by a gem that I'm using in my project. How can I possibly know? I know when it breaks. So that's the problem. How do we solve this problem? What's the solution to this? That's where refinements come useful. The idea of refinements is, it's like monkey patching, only local. It's not global anymore. So I have control of it, right? Here is how refinements work in not even 2 minutes. How do you define a refinement first? It's a two-steps process. First, you define the refinement, then you use the refinement. How do you define it? First, you need a module. We use modules for a lot of things in Ruby. We use modules for mix-ins. We use modules for namespaces. Now we also use modules to define a refinement. It's like a home for a refinement. Inside the module, I have to use this new keyword, refine. I can't remember whether it's a keyword or a method. I believe it's a keyword. I don't know. Does anybody? Who cares? It's a thing, okay? And I say, refine me this class. And now, inside the class, I do exactly the same thing that I did with monkey patching. I define new methods, I redefine existing methods, whatever. The difference is that this time, I'm not polluting the global namespace. It's not even active, okay? I didn't actually do anything. This is just kind of declaration code. Then I need to use the refinement. To do that, there is another keyword or method, and once again, I can't bother to remember which is which, that is called the refine. And you can use it in multiple circumstances. For example, you can use it inside a module or a class. A class is just a module. So I can say using string extensions. And from the moment I use using, the refinement is now active. So I can say hello twice. This only works after the using. It works from right after the using to the end of the class or module declaration. Okay? It's only there. It's local. It's not global anymore. Win. I can also use it in other circumstances. I can use it outside of a module or class. I can use it right at the top level of my program. In this case, the refinement stays active from right after the using to the end of the file. Finally, corner case for completeness. You know that in Ruby, I can take a string that contains a Ruby code, pass it to eval, and evaluate it. I can have a refinement in there as well. It's gonna stay active from right after the using to the end of the string. End of the use cases for refinements. That's it. So, looks like there is no reason not to use this wonderful feature, right? But actually, even if this looks super simple, this is only part of the story. There is something that is not immediately visible going on here. Let me make it explicit for you. What is the problem with this solution to the problem of monkey patching? Well, we said that in Ruby, you can use a refinement inside the class and it stays active until the end of the class. But actually, until the end of the class is not a very well-defined thing. What does it mean, really? What if I reopen the class? Is the refinement gonna be active there? Yeah, no. This is not the only case, because there are multiple ways to reopen a class, all right? Instead of literally reopening the class with the class keyword, I can just inherit from the class. It's kind of like the same scope once again, right? Will the refinement work there or not? And finally, for people who like to play this to the edge of its consequences, there is another super cool way to get into a class scope in Ruby. That's by using the class eval keyword, passing it a block, and the block gets executed inside the scope of the class once again. It's kind of like the same thing in all these cases, right? Once again, is this gonna work? Now, if this works like Ruby works in general, I have to expect that, yes, I expect it works. Because that's the Ruby philosophy. Ruby is a very dynamic language, right? You close the scope, you reopen the scope, you find all the stuff that was in there, like, instance variables, methods, even constants. Xavier can entertain you for quite some time about the scope of constants, but it's kind of like gonna work in all these cases. So I expect it to work. I expect that the refinements do work in this case. This is called dynamic scope, and it's one of the defining features of Ruby. And by the way, it doesn't look like it's gonna pose any danger, right? It looks pretty harmless. Actually, there are a few issues with this. So let me show you 3 issues in particular. First, it makes for some confusing code. How confusing, I will let you judge. Here is an example, a pretty contrived example, admittedly. I have a method that is called add, and it's just calling the plus method. Plus is a method, right? And then I execute this method add in multiple contexts. In the context of one class there, in the context of another class here, and finally I use a refinement module, which the comment says refines the plus method. And then I call add again, okay? Well, with dynamically scope the refinements, I can have a situation like this, okay? So, for example, in the first case, I get 2, as I expect. Probably nobody refined either the add method or the plus method. In the second case, though, this some other class seems to do something with the refinements that I wasn't expecting. Essentially, when I say plus, instead of adding 2 numbers, it converts the numbers to strings and then concatenates them. It was probably written by a JavaScript developer. So now I have something that I wasn't expecting there. And finally here, this other refined version of the class seems to like floating point numbers. So it's not going to return an integer, it's going to return a floating point number. And okay, this looks okay-ish in such a small example, but think about this on the scale of a very large project. Essentially, every time you use a method, in every context, even contexts that are very close to one another, you might have a completely different result. The only way to know what that stuff is doing is to go in, check all the refinements that get used inside each scope. So, is this evil or not? People have different opinions about it. Some people say, yeah, this is evil. This is implementation leaking into the interface. You never know what you're doing. This is super confusing. Other people say, well, this is just a Ruby, you know? You can do something similar with monkey patches already if you try really hard. You will confuse me, and I won't know what's going to happen unless I look inside the code. So there is some debate there. One thing that people of the first persuasion say is this is not only confusing, it's also dangerous, because if I don't know what is happening to my code, then I can easily execute malicious code, for example. People in the second camp say, well, yeah, sure, who cares? You can do that with monkey patches as well, okay? So this is one potential issue. Another potential issue is that refinements have some corner cases that you might not expect. I'm only going to show you one. I have more than one, but I don't want to make this too long. Here it is. I opened pry, and I tried to define exactly that refinement that I showed you earlier on. And then I called you on hello, and it doesn't work. It works in a file, okay? It doesn't work in pry. Can anybody here tell me why this happened? I couldn't think of it on my own, okay? Sorry? Okay, that is actually proof that you shouldn't update your slides the night before the presentation. But imagine that I actually did put the using in there. It still doesn't work. I hate you, by the way. So now, anybody, why doesn't this work if I do it in pry while it works in a file? Huh? You're close.
Because each command is...
Boom. You remember this? A refinement is active from right after I use the using to the end of the string of code. Pry is essentially taking each line, turning it to a string of code, and executing it. So you don't expect this, but this is exactly what happens, which is infuriating. Because you copy-paste code from your program into a REPL, IRB, pry. You expect it to work, and it doesn't. So, probably not what you expect. And finally, there is the third reason why refinements are really considered by some people to be evil, and that's performance. I'm going to explain you in just 2 minutes what's the deal with the refinements and performance. Here it is. In Ruby, when you call a method, what Ruby does is it goes into the class of the object that you're calling the method on, and it starts looking for the method, and if it doesn't find the method, it will go into the superclass of that class. And from there, it will walk up the chain of ancestors of that class until it reaches the bottom of the chain, which is basic object. In this example, we have a class duck that has 2 methods, walk and quack, and it's inheriting from a class bird that has a method fly, and this class is also it's requiring a noisy module. That's how I represented modules in this diagram, which has a method make noise, and it's inheriting from object, which is mixing in the kernel module, and it's in blah, 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 okay? These chains can get really long. So when you call, for example, make noise, what happens is Ruby goes in here. Is there a make noise method here? No. So it walks up, no make noise method. It walks up again, oh, there it is, it calls it. But it, of course, in many cases, it will walk the entire chain. Now, this doesn't look like much, but these chains can get really, really long. I mean, it's pretty normal for example, if you call a method on an active record base object, that has a few dozens of ancestors. It's a very, very long chain. And it happens every time you call a method, which is basically what you do in Ruby all the time. That's what we do in Ruby. We call methods all the time. So actually, it takes a long time. It consumes a lot of the Ruby interpreter's processing power, this process of walking up the chain. So now if I call this method again on another object, I don't want to walk the damn chain again, right? So there is an optimization inside the Ruby interpreter that is called the method caching. The first time Ruby finds the method in this chain, it will say, oh, okay, now I know where it is. It caches that position of the method, and next time I call it, it skips right through the method. And it only invalidates the cache when I change the chain of ancestors. Does that make sense? This is a big deal in Ruby. It's the reason why Ruby is so damn fast, right? Except it's not. But let's say without this, it would be even slower. But once you have refinements, you cannot do this anymore. Why? Because, well, when I call make noise, I don't know where the method is. It depends. It depends where I'm calling it. If I call it in another context, it might have different refinements, and essentially the whole concept of a method cache becomes irrelevant. It becomes useless. You have to look for the method every single time. Which means that, for example, the JRuby people said, we're going to be 20% slower in executing Ruby. Not in executing refined code, in executing any Ruby code. So just by having refinements in there, dynamically scope the refinements, your Ruby becomes 20% slower, even if you're not using refinements. So let's recap the trade-offs. Dynamically scoped refinements are super cool and they fix monkey patching. They are local monkey patches and they are great. Except they make for some confusing code. They have hard to parse corner cases that might surprise you. And they impact performance big time. Is it worth it? This was the debate right before Ruby 2 was out. And in the end, the camp that won was the one that said, no, it's not worth it. This is not what we want. So what did they do? There is a solution to this. I could do this for hours on end. And the solution is, you remember the example I gave you. Here I have a refinement, and it's going to be active when I use using. But whenever I reopen the class, instead of behaving like regular Ruby, where I get into the scope and the refinement is active again, I can say, no, it's not going to be active. When I said it's active from the using to the end of the class, or the end of the file, or the end of the string of code, I literally mean it's active there, period. If I get back into that scope, the refinement is not going to be active. This is the only place in this program where this refinement is active, period. And this is called the lexical scope. Lexical stands for, it's about text. It's active in that piece of text. You can do all the backwards somersaults that you want with singleton classes and class scopes. It's not going to be active again unless you use the using. So let's see what happens now to our example. The first call to add in some class. What's the result of that? Can it be anything else than 2? How? Because it's been monkey patched. I'm trying to fight against Murphy, not against Machiavelli, as they say, right? So bear with me. This is not going to be anything else than 2. This must be 2. It doesn't matter how many refinements some class has. Doesn't matter. Those stay within the class. Here, the refinement is not active, period. Some other class, same exact thing. Doesn't matter. Everything that you have to know is here on this screen. This is 2. Now, ladies and gentlemen, what about this other example? Is that going to be 2, or is that going to be 2.0? 2.0? Does anybody want to challenge that? After you found a mistake on one of my slides, I couldn't wait for you to get it wrong. Yeah, sure. Why is this 2? Lexical scope. I know we are Ruby developers. We're not used to it. Remember what it means. No, it's even worse than that, apart from the block. Remember, what we are saying here, read the comment. Comments are always right. This module here is refining the plus method, right? It's changing it so that it will return a floating point number. This refinement of the plus method is active from right here to the end of this file. And only here does the plus method ever get called in this chunk of text. Not what you expect, right? So it's a matter of debate whether this code here is actually not confusing. Let's say that once you get used to it, you learn to deal with it. But it will catch you a couple of times. On the other hand, there is no performance issue. At least you are not paying for anything here. You are not doing anything weird with the method call chain and so on and so forth. So this is what we are left with. What they did right before Ruby 2 was to change refinements so they were not dynamically scoped anymore. Now they are lexically scoped. This was the change that convinced people that, okay, this feature can get in. So we had a problem, we found a solution, we found a problem with the solution, we found a solution to the problem with the solution. Unfortunately, there is a problem with the solution to the problem with the solution to the problem. You remember why we decided to introduce refinements in the first place? I told you at the very beginning. We have use cases where we want to have monkey patches, but we want them to be local rather than global. First use case, convenience methods. Imagine that you are in an active record or in a Rails class of some sort. And this class is applying refinements so you can have new convenience methods like hours. Can this code work as it is now here on the slide with the current lexically scoped refinements? It cannot. There is no using there. You need to put a using in there. Here, it's not going to work no matter how much I reopen the scope of that class. I need a using, and now it works. But it sucks, because you cannot put dozens of using in your code every time you want to use a convenience method. It's not a convenience anymore. It's ugly. And that's why Rails is not doing that. They keep monkey patching the heck out of it. Domain-specific languages, can these work? The should method. No, you need a using, like imaging these, and then it works. And that's why our spec didn't do this. Instead, they changed the domain-specific language to be, a little bit more respectful of the global scope. They don't pollute it quite as much. But they don't use refinements either. So this is a really weird state of affairs. We came up with a solution to a problem, and after a lot of talking and fighting and struggling, we essentially made the solution so tame that it doesn't solve the problem anymore. I'm not saying that refinements are not a good feature, but all this talk, I've been talking for half an hour already, and all this complex line of reasoning is probably the reason why people say, oh, I don't care. I don't even want to understand this stuff. I will just keep using monkey patches. After all, that's what we've been doing for the last few years, right? Nobody died out of monkey patching. So the question is, was it worth it? Here are the trade-offs in the end. Lexically scoped refinements, not the dynamically scoped refinements, but the lexically scoped ones we have now. they kind of fix monkey patching at no huge cost. There is no performance issue, no huge confusion apart from, yeah, what you've seen earlier on. But on the other hand, you have to call using all the time, which might or might not be what you want. You might say, okay, it's a small price to pay, or you might say, this is not dry, you know? I have to repeat it all the time. It's up to you whether this is worth it, but at least now you know what it's about. You can take an informed decision, okay? And that's what I wanted to talk about. I'm done. Thank you. Buy this book, by the way. It's great. Thanks a lot. I'm honored. Any questions? I'm pretty sure it doesn't. It's still lexically scoped. I mean, even if it did, it would be so magic that I would shy away from it. You know, that's when you really risk. I'm gonna forget about that. Like, you know, shit happening magically because I'm reopening a scope and suddenly I call a hook. I don't know. But in any case, it's not going to work. Lexical, it's about text. Either you see a use right in there or it's not going to work. Yep. No. I don't write much Ruby anyway, and I'm not the best Ruby developer, honest. So it might be that I'm, you know, just a wimp. I don't find convincing use cases. I don't use metaprogramming that much either, to be honest. Still, you should still read the book. Nick? Oh, the irony. Yes. I mean, that was basically, Rails is the major use case for pretty much every new feature. Basecamp, yeah, you're right. You're right. Are you using it in Trailblazer? No, I mean Refinement. Yeah.